question number next question is figure 2 shows a capacitor charge potential 5 volt when the switch is connected to the A. So meaning you can connect to the A here. So this is complete circuit. So meaning this charging process start. Calculate charge in the capacitor when it's fully charged. So we need to calculate the charge on the capacitor here, the Q. So you can use the equation from the C is equal to Q over V. So now you can find the charge on the capacitor is CV, and the C here is 5. This is milli, milli. So 5 is milli is times 10 minus 3, and the voltage provided is 5 volt. So meaning the charge on the bed capacitor is equal to 25 exponent minus 3 coulomb. And number 2, sketch a graph of current versus time immediately after the switch is moved to the B. So meaning if you switch to the B, so now this is a discharging process. So if you look plot graph current versus time for the discharging process, so this is I versus time T, right? So the graph here is like this. So this is I, and this is time T, meaning when the time increase, I is a decrease. And number B, figure show the 3 identical capacitor 2 microfarad. So meaning this is 2 microfarad, and this is 2 microfarad, and this is also 2 microfarad, and connected to the 10 volt battery. And if all them are fully charged, right? Calculate effective capacitance. So to calculate the effective capacitance, consider the C1 and the C2. Because C1 and C2 is series, so meaning you can calculate the capacitance effective for 1 and 2 is 1 over. This 1 over 2 microfarad plus 1 over 2 microfarad. And the next, if you draw the circuit here, so you have only 2 capacitor, right? C3, and this is battery, right? This is battery 10 volt, and this is C3, and this is combination C2 and C1, C1 and C2, and the C1 and 2 and the C3 is parallel. So you can calculate the the total or effective capacitance of the circuit here is C12 plus C3. So if you calculate or put it the value in the equation here, so the C effective is equal to 3 exponent minus 6, right? Alright. And energy stored in the C2. So what is the energy store or the Q? This is not the Q, so I draw this. This is energy. Energy meaning this is a energy stored or energy U2. So the equation is energy is half C C2. This is C at the capacitor 2 and V2 square. Right. So this is equation to calculate the energy store. C half C2 CV square, but this is for the capacitor at the capacitor C2. So now the magnitude of the capacitor C2 is given by the 2 microfarad, but the problem here is what is the value of the voltage here, right? The voltage here. So meaning at the voltage here, because this is parallel and parallel capacitor, meaning the voltage here is also 10 volt, and here is because this identical, 10 volt meaning this is half 10, this is 5 volt, and this is 5 volt. right? Because 5 is 10, and this is 10, and this is 10. This is parallel. So meaning the V2 here is a 5. So meaning if you calculate here, energy store, right? Store energy at the C2 or U2 is equal to half capacitance of the capacitor at the capacitor 2 is 2 microfarad, and the voltage V2 at the capacitor 2 is a 5 volt square, and the U2 is equal to 2.5 exponent minus 5 joule. Thank you.